I'm Ellie Wilson and I'm the current Miss Merseyside, and I'm here today at Coral Vita on Grand Bahama Island, and I'm here with Alana and she's going to tell you a little bit about what the sanctuary does.
So welcome to Coral Vita. We are the world's first land-based commercial coral farm on a mission to restore the world's dying reefs. Also, we work to bolster the resilience of these reefs against the effects that climate change is having on our oceans. I know it may be a little bit far-fetched, why are we saving reefs? Maybe you're not even near an ocean, but I promise you that we are all connected to the ocean, as every second breath you take comes from the ocean, and coral reefs are a very important part of the ocean's ecosystems. And so we're on a mission to make sure that we can keep all of those ecosystem services, or things that we get for free from coral reefs that we need to survive, like obviously oxygen, I mentioned that just now, as well as food, protection, economy. Coral reefs are a really big part of our daily lives, whether you're connected to the ocean or whether you can see the ocean or not. And I'll take you through some of the things we do here at the farm.
So Alana's going to show us around the different tanks and explain what the farm is doing here to create the coral.
Okay, so first question is, do you think corals are a plant, an animal, or a rock?
An animal.
Yes, she knows, yes. Corals are definitely animals. However, specifically these types of corals are a colony of many, many different individual animals called polyps. And if you look super, super close, you can see kind of these little soft tentacles coming out of a hardened structure. Those are coral polyps, and together they are genetically identical and they work together as one complete organism. So here is so here is a coral. Yes, here is a piece of coral that we have brought off of the reef called a fragment of opportunity, meaning that corals, they can naturally break off due to storms, waves, maybe clumsy divers or clumsy boaters, and they can end up in unfortunate situations where they may not grow back. So if they fall in sand, say, there's no hard substrate or hard bottom for them to reattach themselves to. And so usually after events, most recently Hurricane Isaias that was here last summer, we scoured the reef and picked up as many fragments of opportunity or pieces of coral that had broken off and brought them back to the farm to nurse them back to health, and to also make them a part of our microfragmentation process, which is the process in which we can grow corals up to 50 times faster than they would in the wild.
Amazing.
Corals grow super, super slow, and some corals grow faster than others, but they do take a really long time to grow and a long time to mature.
So these pieces are all different pieces of coral that are now maturing?
Yes, they are growing bigger. So they start off looking like this, a fragment of opportunity. We have several different species. This species is Poroides asteroides, or mustard hill coral, because it looks like someone just like squirted a bunch of mustard into a big pile. Scientists are really creative like that. And so the idea is that corals reproduce asexually. They can also reproduce sexually, but we're taking advantage of their ability to reproduce asexually, because if we fragment them into smaller pieces, they are still genetically identical to that parent colony.
Okay.
What's even freakier, I mean, we do this too, but what's really crazy is that if you were to fragment this coral or cut it, it triggers a rapid healing response. Kind of in the same way as if you cut your skin, your body's going to send blood and oxygen and nutrients to that area to heal that skin a whole lot faster. Corals do the same thing. And so it triggers this rapid healing response. So they're growing a whole lot faster. And then the craziest part is that if you have them growing near each other, almost just like this in this setting, once they grow over the cement plug that we've made here at the farm, and if they touch each other or find each other, they actually recognize themselves and grow into a much larger piece in a fraction of the time that it would take them to grow in the wild.
Amazing.
Yeah.
So then you take that larger piece and plant it back in the ocean?
Sometimes, but that is the idea. We don't necessarily have to wait for them to become a whole larger colony.
Yeah.
We can outplant them like this if we want to, but definitely in clumps on pieces we call cookies that we make here at the farm. After we fragmented the coral pieces, we put them onto these little cement plugs that we make here at the farm. And depending on kind of what we're up to or the goal of a particular study, they'll either hang out here in the tanks until we're ready to transfer them onto cookies, which are basically larger cement plugs.
Yeah.
And we'll put a grouping of the same genetically identical fragment onto the cookie, and we take it out to the reef and contribute to the population.
That's amazing.
Speaking of cleaning, would you like to learn?
Yes, I would love to try it.
Okay. So this one's name is PAST 45, and PAST is an acronym for the species name. P for Poroides and AST for Asteroides 45. This tells me that this whole group is one genet, or they're all genetically identical, right? Because you're a human, I'm a human, but you're genetically different, right, from me. Same concept.
Yeah.
So here's your plug, and I'd rather you clean them in the water because they need water in order to respire, or salt water in order to respire. And you're basically cleaning anything that is not part of the coral. Corals they're resilient, but quite sensitive to touch, so I'd rather not touch the coral. You can clean anything else around it. Anything that is not living will gather algae, and we're cleaning off this algae, not because it's necessarily a bad thing, but if there's too much of it, it could smother the coral and prevent it from getting sunlight. Because I know I asked you in the beginning, are corals plants, animals, or rocks?
Yeah.
The truth is they're actually a combination of all three. They have...
So I was wrong.
Well, no, I mean, you were right. I would much rather you said animal than rock, for sure. No, you were 100% right. But they have a microscopic algae living in their tissues, in those little tentacles, and in their bodies, called zooxanthellae, and they have a symbiotic relationship with the coral polyp, like you scratch my back, I scratch yours type of situation.
Yeah.
So the algae gets shelter, and plants need carbon dioxide to create their energy. So they get carbon dioxide from the polyp and shelter, and then in exchange, the coral polyps get oxygen and nutrients.
That's so cool.
And they've been living like that for centuries, for years and years and years. It's a very ancient type of symbiosis, and it's really cool.
Yeah, really cool.
Yep, just like that.
Thank you.
We'll bring those to the lab.
Thank you so much, Alana. It's been absolutely amazing seeing what you do here at the farm, and I'm really looking forward to seeing how Coral Vita helps change our oceans.